What does that xy squared have that I don't have? What am I going to put here and here to make this guy have everything that guy has? What is he missing? An extra y. Because this guy, the xy squared, has 1x and 2 y's. And this guy over here has a 3, 2 x's, and only 1 y. So he wants another y so that he has as many y's as the other guy, right? As many as his neighbor. I got more cars than my neighbor. I'm always talking about my neighbor, huh? Although his 1 or 2 cars, his 3 cars are, I think, way more valuable overall than my, like, 5 old beaters. All right, so now this guy is going to compare it back and say, what does the other guy have that I don't have? What's he missing? A 3 and an x. Give it to him top and bottom. Right? The other guy has a 3 and an x. Because the other guy has x squared, 2x's. I've only got 1. And he's got a 3 and I don't have it. Remember? So we give them what they're missing, top and bottom. Now, why is this a top-bottom instead of a just top-top-top? Remember how we did both kinds? No equal sign. Very good. That just makes a teacher happy to know that somebody's listening to me. Right? Are you hearing that? Right? Remember, there's 2 kinds. There's equal signs where all of our thinking is left-right. Because you got an equals, you got a middle. You got a left and a right. If there's no equal, like this one, I don't see any equals anywhere. No equals, no left-right, it's top-bottom. So we're always keeping some kind of a balance. Are you hearing that? Am I doing the Charlie Brown teacher? Wah, 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 wah. And you're thinking about, what am I going to do this weekend? Oh, it's Monday. I got 4 more days. Right? Are you dialed in with me? I remember, I learned a lesson about teaching my second year. I was teaching this class I was in Stockton at Delta Community College up there in Stockton. Anyway, big class, 40, 50 people, and in the back, so I'll get that. So I passed out a lab. I was passing out to do some kind of lab thing. Anyway, and I accidentally passed out my answer key, which was fine. It wasn't a test or anything. But I had solved all the problems, and so I realized it. I stopped class and I went, hey, I accidentally passed out my lab. It was in the middle of the pile, I guess. Anybody got, my key. Anybody got my key? It's got red writing. All the problems are solved. The rest of them are blank, right? I solved every problem. Red, pen, writing, all over it. Anybody got, I made it kind of a big deal for about 5 minutes. Nobody. Maybe I left it in my office room. I don't know, whatever. All right, I'll just solve them as we go. So I just put it on the overhead, and I just start solving them as we go, back in the overhead days, it was like 20 years ago. And then about like an hour into lecture, a young lady from the back of the room, she raises her hand. Mr. Heron, I got something funny all over mine. She holds it up. There's my key. Red writing all over it. And I remember I was nice and said, oh yeah, that's my key. And I remember going back to my office that day and I thought, wow. I understand they're not hanging on every word I say. But I made a huge deal out of that for like 5 minutes. Stop class. It's not hard to tell. Blank or red writing all over it. I thought, what is going on in her brain when I am doing that big? She is like, woo! Where am I ever going to get married? She's just not there. I remember thinking, wow. That was a lesson for me, that how much checked out somebody could be when I'm talking. So anyway, that day I realized I'm going to need to repeat if I'm going to get across what I'm saying. So y'all hearing me? I'm not doing the 1-1-1. You got to catch this, or you're just killing yourself in this class if you're thinking about the weekend already. Equal sign or no equal sign. Huge difference. Huge mountain of difference. No equal sign, top, bottom. Right? Equal sign, left, right. Because there's an equal in the middle, left, right. So you want to think that way. Equal sign or no equal sign? So this is no equal sign. So there's no left, right. So all of my work is going to be top and bottom. So you see how I'm doing the same thing right here? To the top that I am to the bottom, to the top that I am to the bottom. So I don't change the fractions. But in a minute, in fact, all that we're going to do today is really going to have equal signs. And we're not going to do top, bottom. I'm not going to mess with the bottom. I'm going to do left, right. Top, 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 which is really left and right, not bottom. Right? Got those 2 ideas down? Really, really important. Okay, so what do we got here? This y is going to go boom, boom, like that. And then I'm going to get what? 6xy plus 5y squared over, it's going to be the same common denominator. They're both going to be what? 3x squared, y squared, aren't they? Both these denominators are common now. We made them the same. We gave them what their neighbors had, so they both have the same stuff. They both have a single 3, 2 x's, and 2 y's. 3x squared, y squared, don't they? Did y'all see that? How we doing? Does that make sense, right? This and this are now the same, so we don't need two of them. One big fraction, right? What happens here? Boom, boom. So that's minus what? 12x squared plus 12xy. That's just like it, right? Oh, no, can we? Oh, I guess this and this can combine as like terms, huh? And then we're done. It doesn't matter what order you do that in. Doesn't matter at all. Maybe I'll just put the y squared in the front. Who cares? 6xy and 12xy. What's that? 18. Xy and 5y squared over 3x squared y squared. Yeah. Wait, it's a little off the screen. That screen thing here. So this is, what was this middle one? 5y squared plus 18 xy plus, no, minus 12x squared. Is that on the screen? Yeah, all right. There we go. And that's it. Was that answer C? Answer C, if you go back to the thing, that indeed. Oh, they put the minus 12x squared in the front. Yeah, like I said, the order doesn't matter. They put that. Do you guys know that, right? I guess that's important for the test we take. When's our test? Did you guys look at the schedule?
Monday.
Remember, you got it. You don't need me to tell you. It's on this, right? Monday, week from today, is big exam number 4. So in other words, this and this, I put the minus 12x squared at the front. Oh, oops, I'm on the wrong screen, huh? Back to here. Yeah, so I just swapped these guys right here. It doesn't matter what order you have it in. Right, same answer. Is that good? Questions I can answer on that? We good? This exam's going to be harder. This will separate the men from the boys. Sorry, ladies, but you know what I mean. It's going to really, it's, actually, you know who are all the strong students have been in almost all of my classes for 24 years now? It's always the ladies. Almost without exception. My top 2-3 students always feel, so I want to say, come on, guys. Come on. Let's do some work. It's the guys that I can't get moving. Get them moving. Let's go. Let's do some homework. Let's get it going. It's always the ladies that are my high scorers. Yeah.
Sorry, first one for me, but is there a reason why my grade on my math lab is still the same? Have you not on math lab?
Oh, is something seem funny?
Yeah, my grade's been the same exact percentage since last week on the, or.
Oh, yeah. Yeah, it only updates every exam.
Oh.
Yeah, and even though you're doing homework, right. I'm telling what I have to do, yeah. So, yeah, and you know how it says omitted on the homework? Yeah, that's okay. It's I don't want to worry too many details, but real quick, I have to tell the computer to not put the homework for the rest of the semester into your grade. Otherwise, it will give you zeros on everything and bring your stuff you haven't even got to yet. Bring your grade way down. So I tell it, ignore all that future homework. And then every time we hit an exam, like when we hit on Monday exam 3, I'll say, okay, computer, go back and grab all the homework up to exam 3 now and put that into the grade. So it knows it's there, it's just not factoring it in yet. So nothing's changing until we hit exam 3. I just do that, I just update everything. So it's got it, it knows all those numbers, yeah. All right. So we good? Yeah, let me just say one word about this one. This exam really, exam 4 and 5, and you guys have been like my star class. So I'm expecting great things. Exam 4 and 5, but I want you to know, part of, if you're a baseball team or a soccer team and you're going up against the big guys, you got to know it, right? Or the big team. So 4 and 5 are harder. Exam 4 and 5. Not that I'm doing anything different than I've ever done. I'll do the same thing. Practice exam, it'll be just like the practice exam. I'll review with you the first hour. I'll do all the same stuff, but I'm just saying the material's messier, huh? I mean, you can see that. You don't need me to tell you that. The material is just messier. It's uglier. There's more steps, more to remember, more to do on exam 4 and 5 than the first 3. So my point is, if you want to keep getting, if you're getting A's, that's great. Or B's or whatever you're hitting, you're probably going to need to raise your level of work if you want to still hit at the same level. The average will drop, typically. The average drops by more than a grade on exam 4 and 5, just because the material's messier. So I want to give you a heads up. That's not to discourage you, that's to encourage you, right? I don't want you to be surprised when you hit exam 4. So if you study the same way you have, you'll probably be a grade lower or more on exam 4. That's what the average will do. But that doesn't mean that has to be you. Raise the bar, right? Study harder. Study harder. Go over this stuff more. Go over that practice exam again and again. Before I do it on review day, I hope that's not the first time you see that practice exam. I mean, you can do that if you want to, but that's not a good student, honestly. That's not what a good college student does. So a good college student would go over that practice exam several times before exam day. That's what you need to do if you want to do well on 4 and 5. It won't come as easy as 1, 2, and 3 did. But you guys are going to do great things. I'm very hopeful. I'm like, there could be like an 80% pass rate in here. That would be amazing. I don't think I've ever had. Well, I had 100% pass one time, but there was only 6 students in that class. That was fun. We had a good time. I was able to help all 6 individually, and they all passed. In fact, they all got A's. One guy got a B. He was a little disappointed to be the only B. But anyway, it was. It's always one of the guys. You know, all the gals got A's. Anyway, but that was the great. But that's the only time I've had 100% pass. So, otherwise, I'm around 60 to 70% pass rate. You guys are hitting around 80. This is all right. Let's do it. There's going to be 3 kinds of word problems in this section. So I'll show you the 3 different types. 2 of them will be pretty easy. 1 of them will be more challenging. So here's an easy one. Jack usually mows his lawn in 6 hours. Marilyn can mow the same yard in 7 hours. Big yard, I guess. How much time would it take for them to mow the lawn together?
Golf course.
Yeah, it's a half a golf course or something, huh? So 6 hours for Jack, 7 for Marilyn. Yeah, it must be. How long together?
Can you times it?
6 times 7, 42 hours. That seem right? No, I'm just throwing ideas out. What do you think? Should we add them? They're working together. Add them together? What do you think? I mean, how do we do this? Any ideas?
Well, it's going to be a fractional proportion because it takes 6 hours to mow one lawn.
Right.
For Jack.
Right.
And then for Maryland, it takes 7 over 1
Okay.
to do the same lawn.
Yeah. So how long together?
I forgot.
What do you think? Any ideas? Should we add them or multiply? Which one of these is right? Neither? How do you know? Yeah, it just seems crazy, doesn't it? Yeah. Yes. How about this, guys? How about if we add them and divide by 2? Like average them, get the middle? Does that seem reasonable? 13 over 2, if you divide that in your calculator, you get 6.5. Does that seem more reasonable?
Yeah.
Does it?
No,
Why not?
because one does it in 6 hours, one does it.
Yes. Thank you for thinking today. Are we all thinking? Look at Jack. He's like, look, I can do it in 6 myself. So Marilyn helps, and now we're at 6.5. Marilyn's not much help, right? They're not getting along too well.
It should be a little.
The answer's got to be lower than 6, doesn't it? It can't be higher than 6. I hope nobody can convince you that it's higher than 6. That would be wacko, right? Jack can do it alone in 6. The answer's got to be lower than 6, doesn't it? So that's all craziness, isn't it? All right, so enough with the crazy ideas. Let's do the real thing. I just wanted to show you, though, just thinking reasonable. It's always good to have kind of an air of reasonableness about you, because it's so easy just to accidentally multiply the wrong number. I've seen a lot of students on a lot of exams, they'll get the answer 10 hours, and they'll just put a box around and go to the next problem. I want to say, hello, really? Could it be 10 hours when Jack can do it alone in 6? You think? Right? Keep reasonableness with you when you're doing a word problem. Stay in reality, right? Don't just move numbers and letters and bang, there it is, next problem, right? Especially on a test. I mean, I know homework, you're just trying to get it done and stuff. But in a test, and it's multiple choice, don't be grabbing a sucker answer like that, right? That answer should make you laugh. You should look at that and just laugh. No way. That's ridiculous. Can't be longer than 6. That's the sucker answer, right? You guys aren't going to go for that kind of stuff, right? So, all right. So just have an air of reasonableness about you. Now, here's the real way to do it. 1 over A plus 1 over B is 1 over together. This is the formula when they are working together. Working together. 1 over a plus 1 over b is 1 over together. I'm using a little bit of a different formula than Math Excel. If you click on the help button, they do something similar, slightly different. I think mine's a little easier. I try to not deviate from them, but sometimes it's worth it. All right, so here we go. So it's 1 over 6. I think this is what you were hinting at with the fractions. Plus 1 over 7. And the together, I don't know how long it takes them together. That's what I'm trying to find out. Just call that x. Everybody good so far? So the a and the b are the two individuals. The x is the together. There's my equation. So the words are over. I have an equation now. I just need to solve that equation and I'll have my answer. But how do I solve that equation? LCD. Very good, guys. Very good. And how do I find the LCD? Yeah, totally. I would just multiply the denoms. Is that on the screen? Kind of. Together. Yeah, I think the easiest way, guys. Remember, LCD is just one of each type. Remember that? Whenever we form an LCD, it's just one of each item. So I would just take a 6, a 7, an x, multiply that all together, 42x. Yeah, exactly. So the LCD, that's what we'll always do on these, is for the LCD, we'll just multiply together all the denominators. 6 times 7 times x, 42x. Now, I've got the LCD. It's 42x. What am I going to do with the LCD? This is where that spiel I gave you. Is my thinking on this problem top-bottom, or is it left-right?
Left-right.
Yeah, because we have an equal sign. Equal sign. So the quiz did not have an equal sign. So I did top-bottom, huh? This one does have an equal sign. So equal sign means left, right. In other words, top only. I'm not going to do top and bottom. So I'm going to take that 42x, I'm going to go top only. Top only, top only. Does that make sense? See how I'm doing the top on the left, all the tops on the left and all the tops on the right. I'm doing left, right. I'm doing the same thing to the left that I do to the right. I'm not doing top, bottom. I'm not even doing the bottom at all. Does that make sense? All they would have to change on the test, and they will, that's why this test is hard, they had a plus sign. Then I would have to do top and bottom, wouldn't I? Then I would do the give them what they're missing, the neighbors thing that we just did on the quiz. Everybody see that difference? It's all about the equal sign. That's a huge difference in algebra. You want to really think that way. Equal sign, left, right. No equal sign, top, bottom. Okay, so left, right, here we go. What do we now do? Yeah, let me just write a note here. Cross cancel, remember these? Good, exactly. Cross cancel and multiply leftovers. Remember how we did a lot of that in last night's homework? We did it in class on whatever it was, Wednesday. So 6 goes into 40. Just use your calculator if you're rusty at all. 7 times. Now notice how I actually cross. This is what I see lots of students skipping, and it's to their own harm. Don't skip it. Cross off the 6, cross off the 42. Make sure you cross them off, so you know they're gone. And the 7 is not gone. He's still there, right? So these guys are gone. 6 and 42 are gone. Please cross them off. I don't know why everybody just wants to leave them. No, we need to know they're not there anymore. 6 and 42 divided. So what's left? Yeah, what's not crossed out? What's left over? Because I said multiply the leftovers. What's left over? 7 times x times 1. 7x. Right? 7 times 1 is 7. Times x is 7x. Good so far? Can you do the middle one? Do the same thing. Cross cancel. Divide on the calculator. But make sure you cancel out what you divide, and then whatever's left over, you multiply. Yeah, so it's going to be 6x, because 7 goes into 42 6 times. What's left over? 6 times 1 times x, or just 6x. Good so far. And then what will cross cancel on the right side? Just the x's. What's left over? 1 times 42. They're multiplying, right? They're not adding. They're multiplying. 1 times 42 is just 42. No more fractions. Isn't that nice? No more fractions. So then, yeah, now we just do like terms. 13x is 42. How do you solve for x? Divide by that 13, and we got it. There's our answer. That's fine with me to leave it that way. Yeah, that if you're interested, you get a decimal or mixed number. It doesn't matter to me. 42/13. Now, somebody have a decimal on that? I'd like you to see the decimal. What is 42 divided? It's 3 point something, right? 39. What is it? 3.23? Yeah, and that's hours. And it makes sense, huh? That's little over 3 hours, because one person could do it in 6 hours, one in 7. So if they work together, it makes sense it'd be around 3 or 4 hours for them to work together, right? That's a reasonable answer, is what I'm saying. That makes sense, doesn't it? Is that good? We okay with that? Questions? Really good with these. Here we go. Let's try this one. So Lisa can shovel snow from her driveway in 65 minutes. Tom can do the same job, 45. How long would it take Lisa and Tom to shovel together? Same thing. What's the formula we use for working together problems?
1 over A plus 1 over B.
Yeah. Just put this on your 3x5 card, right? It's always like that. 1 over A, 1 over B, 1 over together. And you know the right side's going to be 1 over X. And as far as the 65 and 45, I would just multiply those together in your calculator. I mean, you can do the, you know how we did the box, you might be thinking, if I was you, I'd be wondering, what about the box thing, Mr. You're right, you could do the box thing, but I think it's easier at this point just to multiply together, just quicker. Either one would work. Either one would work. So LCD would be 65 times 45. Tom, don't forget the x. The x is in a denominator, right? Somebody have that number? Is it really big? 25,000, 2,500?
29,000 or 2,925.
Thank you. X, right? 2925x. You guys getting that? Definitely want a calculator on this exam we take next Monday. It's got some big numbers like this one. Actually, you know what, guys? I think I can make it even a little bit easier. You could actually just leave the LCD like this and not even figure out what that number is. Just say, hey, it's all three. Remember, because LCDs are one of each, right? So just put the whole, you could just go, look, I'm just going to put 65, 45x, 65, 45x, 65, 45x. Either way, or you can put that, whatever, 29, 25 number. Either way, I think this might be quicker, though. Just put all three of them. Top, 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 huh? Only top. Why? Why not? Why not bottom? Why am I not doing top, bottom? Equal sign, right? Equal sign means left, right. Not top, bottom. And then cross cancel and multiply whatever's left over. Second to wrap that one up. So we cancel, right? So 65 cancels 65. What's left over in that first one? Yeah, 45x, huh? We good there? So remember, you cross cancel, and whatever's left over, you multiply. Keep going.
65x.
45 cancels the 45. What's left over?
65x.
65x. Is that good? The 65 and the x. And then what cancels on the right side? Just the x's. That good? And what's left over? 65 times 45. And that's where that, what was it, 2925 number? Comes in. Is that good to there?
You get 110.
Okay, add those up. 110x. And then divide, huh? Divide by the 110. And I think we have, this is the answer, except it can be reduced. Do you see that? You know, all fractions that can be reduced must be reduced. Yeah, what could you tell goes into 2925 and 100? Those are big numbers. Yeah, can you tell that 5 goes into both of them because it ends with a 5 and ends with a 0? So divide by 5. So I have no idea. What was the answer again?
I got 585 over 22.
585 over 22. Is that good? You guys getting that okay? Just like that. If you guys have the Casio natural display, it'll reduce those fractions automatically. Good. Questions I can answer?
I just about mine.
Did you?
Like, for the longest time, I couldn't figure out how to get decimals on it.
The SD?
Yeah, because it was just giving me my
Yeah.
answers and fractions.
Right. Yeah, that SD button will rotate between all the different forms of the answer. It's really nice. Anytime you want decimal fraction, whatever.
Figure that out.
And for the 2925, you guys have the Casio natural display. Want to take the 2925 over 110, enter it as a fraction, you know, the fraction button. And then hit enter, it'll reduce it automatically. All right. I'm sure some other calculators do it too. There's no surprises. All right, so try that. The Office Jet printer. You know, you don't even need to read all those words. Blah, blah, blah. One thing 12 minutes, other thing 22. How long together? You know, they're all the same. Just do the same old 1 over A, 1 over B, 1 over together. Same thing. Yeah.
What'd you get?
This is your fraction, right?
Who did that? Multiply?
We hit the fraction. Did you do it?
No.
Oh, no. But the original. The original was divided by 110, right?
Yeah.
Divide by 110. Yeah. Yeah, so it makes a fraction. 7, 29, 25. We're gonna make fraction. No, we're gonna make fraction first.
34.
Really? Oh, nice. Just like that it even does it. Wow. That's great. And if you ever need a decimal, you don't get a decimal if you ever need it. SD. Yeah. Boom. Back again. Yeah. Beautiful. Yeah.
Over 7.
Worth the money yet?
How'd you get that?
Not yet. After the test, I'll let you know.
This is a fraction button.
Come on, get used to it. Gotta get it boy, you
And then so this one,
It's the same.
and these are jam.
know what you said, how'd I got that? Guess what's in there?
Because I have between.
I like this one.
And then also, if you ever need to get.
But you said there's 3 of those, so this is the first one.
Whatever you look for,
Huh? Who? Did you try my mattress?
now if you want to go back,
Can believe they moved. I'm kind of like that. They moved the space. The one that dark.
all right, you get this one. So 1 over A, 1 over B, 1 over together. So the 12 and 22, right? 1 over 12, 1 over 22, 1 over X. What do you do for the LCD? It's 1 of each. 12 times 22 times X. Is that good? That's what we always do for the LCD, 1 of each. So 12 times 22 times X. 12 times 22 times X. 12 times 22 times X. These good? You do these in your sleep now, right? You just, the LCD is 1 of everything, and you put it top, top, top because of the equal sign, huh? Is that good? And then we cross cancel. 12, 12, what's left? 22x. Cross cancel, 22, 20, what's left? 12x. Cancel x, x. 12 times 22?
64.
264? Thank you. 264. Add these together, what is that? 34x? 264 divided by 34. You can, yeah, you can, your calculator, you can reduce it. Was it 132 over 17?
Yeah.
There it is. Or some decimal thing, whatever that be. 7 point something. 7.7. Good. We good? Make sense on these? Working together, probably. So there'll be one of these on the exam Monday. And you'll recognize it. It'll go blah, 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 working together, you know. So have that little formula on your 3x5 card. The 1 over A plus 1 over B is 1 over together. There'll be one of those on the exam. All right, so we're going to use distance. Oops, let me put a different color here. We're going to use distance equals rate times time. And I'm actually going to make 2 boxes underneath each letter. So 2 boxes under D, 2 under R, 2 under T. And what are the two kinds? There's a passenger train and a what? A freight train. Right? So right across here is passenger, right across here is freight train. So we're going to have 6 boxes, 2 underneath D, 2 under R, 2 under T. We'll always use distance equals rate times time for travel problems. There'll be 1 or 2 travel problems on the next exam. Probably just 1 on that. Okay. Before we dive into the details, let me make sure the boxes are making sense for you. Like if I put like a 10 here, what would that I'm not going to really put a 10 there. There's no 10 even in the problem. But, I mean, what would that really mean real life if I put a 10 in that box? Notice it's in the distance passenger box. 10 miles, for example, means the passenger train went 10 miles. That's what that would mean, which is not true. But that's what that would mean. Are we all making sense out of the meaning of that box? What if I put a 10 in this box? What would that mean in the real world? The freight train went a distance of 10 miles. What if I put a 3 in this box? What would that mean? That would mean the rate of the passenger train was 3. Rate, what's rate? Like speed, like miles per hour, yeah. Like the passenger train was going 3 miles an hour. What if I put a 4 in this box? What would that mean? The freight train was going at a rate of 4 miles an hour. What if I put a 7 up in this box? What would that mean in the real world? Yeah, time for the passenger train. Passenger train was traveling for 7 hours maybe, or 8 in this box. The freight train was traveling for 8 hours. So I want to make sure you're good with the real life significance of the various boxes. Okay, I just messed up my whole picture now. Let me go back. I had a student years ago. He was in that class. He was the one that got the B in that class with six students, and they all got 5 A's and a B. Anyway, and I remember him saying, we were doing some travel problems in that class, and he said, "You mean the dirt equation, Mr. Heron? The dirt equation?" And I thought, yeah, that works. So if that helps you remember the word, it's like the word dirt. It's like the equals is an I, right? Almost looks like the word dirt, the dirt equation. Distance equals rate times time. All right, so going back to it, passenger train and freight train. All right, so now here's the deal. Here's the plan. Let me give you the plan. Number 1, get 4 boxes. Is that on the screen there? Yeah, get 4 boxes from the words. We always get 4 boxes from the words. Then last. Wait, Pedro. Oh, I don't know what to do. $220 miles. Do we know the rate? We do. Oh yeah, I see. So the last 2 boxes. Have we done travel before in here? No. Last 2 boxes. D over R is T. Can you read that okay? T equals D over R. And then step 3, yeah, remove last 2 boxes, right equation. So there's our 3 steps. I don't know if I write this a little neater because it's real important. Distance over rate equals time. Yeah. Okay, so there's the game plan. Get 4 boxes from the words. Get the last 2 boxes from the T equals D over R. And then remove the last 2 boxes and write an equation. That's the game plan. So here we go. First, let's just go through the numbers one at a time. 14 miles an hour faster. Let's come back to that one. That's the hardest one. Let's go on to those. How about this one here? 290 miles. That's the next number I run into. Yeah, miles, is that a distance, a rate, or a time? Miles. That's distance, isn't it? 290 miles. Miles is distance. So it's going to be one of those two distance boxes, huh? Does that make sense? The 290 is going to go in one of those two distance boxes. How do you know which one? It says passenger. Passenger train's 290 miles. So that 290 goes in the passenger distance box. Good so far? And then what's the next number? The 220 miles. That's distance. So that's the distance for the freight. It says freight train, doesn't it? Yeah, freight. There it is. That's the freight train distance. So we got two boxes. Now we got to come back to this 14 here. Okay. Now, remember in word problems, all word problems, what do you do what if you're reading a word problem and it says blah, 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 3 more? Well, X plus 3. Doesn't it mean that? Right? Remember how in word problems, there's always one piece that's just simple X, and then like another piece that's an X formula, like X plus 3 or X minus 7 or something like that. And how you know is because they'll say blah, 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 3 more, then it's X plus 3. Or blah, 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 4 less, so it's X minus 4. Right? Bigger is add, less is subtract, times is times. So you go 7 times and 7 times. Right? But hear me on the main point. One box will always be just simple X, won't it? And another box will always be some kind of X formula like X plus 2 or X minus 3. Always, I mean almost, like 99% of the time. That's how they do all word problems, right? Okay, so what do you think? So that hasn't changed. That's still the case. 14 faster. Yeah, isn't that like saying 14 more? So doesn't that mean X plus 14? Absolutely, exactly what it is. And some other box must be simple X, huh? So now how do you know which one goes, are they faster? Is that a distance, a rate, or a time? Faster. That's a rate, that's a speed. Rate is speed. So that's rate. So it's one of these two boxes. Yeah, what does it say? Passenger is 14 faster. So the passenger, 14 plus X, or X plus 14. If that bugs you, you can put the X in the front. It doesn't really matter. I'll put the X in the front. And what's the other one? Just X, because one of the boxes always just X. That makes sense? How we got to there? It's just like the other word problems, huh? They'll always say blah, 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 3 more, whatever, X plus 3. And the other one's just X. They will always do that in word problems. Okay, so step 1, get your 4 boxes, check. Step 1's over, check. I got my 4 boxes. Step 2, how do you get the last 2 boxes?
You come up with a formula that will give you the time that.
Yeah, distance over rate box is the time box. Just, what am I talking about? Take the D over the R and put it in the T. So 290 over X plus 14. And the D over the R and put it in the T. Everybody see that? What I did there? It's just the D over the R, put it in the T. D over R, put it in the T. Hey, why is that right to do? You know all I did, guys? That's really simple, actually. I just took the D equals R times T, right? That's the equation here. Equals and times, right? And I just said, look, I'm trying to find T. The T was the blank box, right? How do you solve this little equation for T? How do you solve this little equation? You divide by R. So you see, that's where I came up with T is just D over R. You don't need to do that. I'm not saying you need to do that. I'm just telling you, where did I come up with this thing? Well, I just solved the little dirt equation. I just got T alone, and it was equal to D over R. That's how I know the T box is the D over the R, and the T box is the D over the R. Because that's the relationship between those 3 letters. All right, anyway, you don't need to do that. Just divide them. It's all good. Step 2's done. Step 3, remove those last 2 boxes and write some kind of an equation. So now we don't even need the first 4 boxes anymore. They only were important as they led us to the last 2 boxes. So grab out the last 2 boxes, 290 over X plus 14 and 220 over X. Grab out those 2 boxes and write some kind of equation. Can I just make them equal?
No.
No? I think yes. Why is that right to do? Let me give you 2 reasons. Number 1, there's no other numbers. That's not really logic, but I'm just telling you that's how they write these problems. If they see how I've used all the numbers in the words, there's no other numbers. Whenever all the numbers are done, you just set these equal. If there was some other number still I hadn't used, like 5 or something, I might think about adding 5 or doing something with a 5. But there's not. I've used all the numbers. These are just equal. That's just me telling you, hey, here's how they write these problems, guys. So that's not really like logic in the real world. But let's go to logic in the real world. What reasonable fact of real life says that these two time boxes, right? Remember, these came out at time. This represents an amount of time. This is the time for the passenger train, and this is the time for the freight train. Why would the time for the passenger train equal the time for the freight train? What do they say in the words that says those two times are really equal?
X plus 14.
Say same time.
There it is. They're saying it. They're just saying it. Same time. Everybody okay with that? Can I move on? Everybody got that copied? All right. Let's try this one. Speed of train A is 18 slower. 18, so let me just jump in right now. 18 slower. What do you do with that? Isn't that like 18 less? Isn't that like slower? Isn't that like less? So what are you going to do with 18 less? X minus 18. Right? And somebody else is going to be. You know what's coming. These are so predictable, right? Anyway, you first need the dirt set up, right? So right away, you just set up the dirt with the 6 boxes, and you need to get 4 boxes. And then the last 2 come by dividing, right? Same kind of thing. Let me know if I can help on words or about. Give it a little bit of extended time. It's really hard. Let me know if I can help. It's almost over.
Yeah. I was born, not even caller ID was out when I was born. There was no caller ID, there
Well,
was.
I'm 17 years older than you, so I was born where no internet.
Oh, yeah, there was only internet in 93.
Okay. I don't know if there's a college.
Slower means minus. So X minus 18.
You guys doing okay? The dirt equation. And we got train A, train B, right? Want to get 4 boxes from the words, and then the last 2 from dividing, right?
Get it, let me try.
Feel free to check with those around you. Grab those out.
Track which one?
You can subtract this, because then this will become negative and you divide by 8.
For minus 18.
And then do that, yeah.
Pretty simple. What's that? The other ones are right.
right, we doing okay?
These aren't that bad.
A's 18 slower. Slower, that's a rate fact, huh? So it'd be x minus 18, the other one's x. Good there, and the 230 is the A, and the, what, 320 is the B? Everybody getting those 4 boxes okay? And then you know the last 2 come by dividing, huh?
4 goes right here, and 46 goes at the bottom.
No, the other way around. Because on 230, you're subtracting the 18. Going with the x. The x is just this. So you subtract it to this one, so you get 46 at the top. You understand?
Like the,
You understand?
alright. Oh, shit.
All right, we doing okay? Those last 2 come by dividing, right? Left over middle, so 230 over x minus 18, what's 18, and 320 over x. And then you just grab out those last 2, and you set them equal to each other, right? Like that? Is that good? And then you go diagonal, diagonal. So maybe I'll put it right here. 230x equals 320x minus 18. We all good to there? Okay. And then distribute, right? Whenever you got parentheses, you got to distribute. And that's 5760?
Yes.
Oh, it is. Thank you. Okay, and now what do we do when we have the walls here and we have x's on opposite sides?
Subtract.
Yeah, get rid of the one that's got more stuff with it. Yeah, get rid of the 320x from both sides, right? Because that'll get rid of that.
90x.
What is it?
Negative 90.
Thank you. Negative 90x, and this is the negative 5760. And last step?
Divide by 99.
Yeah, just divide. Negative 90. X, is that what it is? 64? Okay, now that's the key. We can unlock any door. We just got to ask what doors do they want to unlock. Speed of train A. Which boxes? They're going to ask for 2 of those boxes. That's right here. It's rate of train A, huh? So take that 64 and put in 64 right there. Minus 18. What's that? See why I'm doing that? Because they're asking for the speed of A, the rate of A. So I use that X, 64, like a key to unlock those 2 doors. What is it again? 46, thank you. 46, so that's 46. And the other one is just simply X, so it's just 64, huh? There's our 2 answers. We're able to find the speed of both trains. We leave that up for a second. Questions I can answer on that? Yeah. You got. Yeah, I'll come by too. Maybe one of your steps went wrong. It should be positive. It should be just like that, positive. I can come by and check why you got negative on that. Right. Yeah, right here when you divide 2 negatives, make positive. Yeah, right. Thank you. Is that good? Double check on that. Other questions I can answer? Good. So if you're getting these, you're doing well. This is the hardest kind of word problem we'll do in this class. I think. Good. Can I move on? We good? Okay, this is going to be a little tricky. They're going to throw a little more. They're going to throw in a curveball at us now. So write the dirt equation, the 6 boxes.
Can't read all of it. You need it over there.
I wonder if there's anything important. I know it's this silly projector.
Does it say 2 hours?
Oh, it does. And that's important, too. Yeah. Double speed, 2 hours less time. That's super important. It's off the screen. Thanks. Yeah, it says double speed, 2 hours less time off that screen there.
You're only getting one.
Give it a try. Set up the dirt. Remember, you need the first 4 boxes, right? See if you can get the first 4 boxes from the words. Didn't it say train A was equal to slow?
It's the same.
And then this one. Slower is 80. Faster is plus.
So the return trip to me whether if it comes to double the speed in 2 hours less time. The return trip
Everybody got it?
So less
2 hours less time.
So less minus 2.
You
How
do
we
an hour,
doing?
32 minutes.
Oh, I wrote it right here for you. 2 hours less time.
You were saying they pick on little teams, make it smell like Costa Rica. 4-0.
That's right. Remember Mexico?
Thank you.
Remember Mexico?
Everybody getting that copy down? We good? Let's try it. Distance equals rate times time. So we're going to do the 6 boxes, 2 underneath each letter. We have a long distance trucker and the return trip. So there's the trip and the return. So this time we don't have 2 different cars or whatever. We have just the truck itself, its original trip, and its return trip. Those are the 2 travelings we're talking about, right? The long distance, 80 miles in one direction. 80 miles.
Same on both.
Yeah, I know. The distance doesn't change, does it? Good. I'm glad you're thinking reasonable. It's always good to keep it 1 foot in reasonable reality. Yeah, it's 80 miles each way, huh? Yeah, good. Okay. The return trip, double speed. Can you get that? Double. What does double mean? If I said, I'm 30, my brother's double my age. Times 2, huh? Double is times 2. 2x. Very good, very good. Yeah, so the return, double speed. So it's 2x, and this is x. Does that make sense? We good so far? Right, so this is, instead of saying more or less, right, the last 2 problems, so it said, more, so that was add, x plus 5 or something. Less, be like x minus 5. This is double, so 2 times x. The return is 2 times x. Now, what are we going to do with this 2 hours? I don't care right now, because remember, I'm not supposed to be thinking about that right now. Remember what my instructions said. This is why I carefully wrote out the instructions to really help, especially on these more tricky ones. I said, step 1, get the 4 words, get the 4 boxes from the words, and then step 2, how do we get these last 2 boxes? Dividing. By dividing. Remember, the last 2 boxes, if you look back to my steps, right here, last 2 boxes, T is D over R. You divide, huh? Remember that? So I'm going to get these last 2 boxes by dividing left over middle, left over middle. Is that good? I'm not worried about this 2 hour less time thing right now. Right? See what I'm saying? You just get the right 2 boxes by dividing left over middle, left over middle. And then you pop out those last 2 boxes. Right? And normally, at this point, we say they're equal. But this one, now we're going to use that 2. This is where we'll use that 2. This is the extra wrinkle. Everybody see what I'm saying? Normally I just set these equal, but not this time. Why not? Well, because there's another number I haven't used. Not only that, it doesn't say same time anywhere, like it did on the last 2. Right? On the last 2 problems, let me show you. Let's go back. See this one? Well, for sure on this one. Remember I circled same time right here? Same time. This other one, it implied, oh, yeah, this one also. Same time, right? In the same time. See how all those other ones, it kept saying same time, same time, same time. So the 2 time boxes were what? Equal, weren't they? But this one doesn't say same time. In fact, it says 2 hours less time. They're not same time. One of them's 2 hours less time. Does that make sense? So I can't set those equal. So yeah, so what do you do with less? You subtract them, exactly. You subtract them and set it equal to 2. Does that make sense? Let me stop for a minute and be real with you. What if I said, hey, there's my age and there's my brother's age. I'm the older. So there's my age, there's my brother's age, and my brother's 2 years less. He's actually 3, but let's say it was 2. What would you do? Wouldn't you take my age minus my brother's, and that would be 2? When somebody's 2 less, doesn't that mean the difference is 2? The subtraction is 2? Isn't that what that means? When somebody's 2 less or 3 less? When somebody's less, that means the difference is that, right? That's why I'm doing this. Does that make sense? They told me 2 hours less time. Good? See that trick? All right, so now we got to solve this equation. And this is harder because it's not just one fraction on each side. We can't just go diagonal, diagonal. You see the difference? See, let me go back. See how over here, this last problem, it was just one fraction on each side. We just went diagonal, diagonal.
But since we can't set it equal to each other, you have to do like we were talking at the very beginning of
We're going to do LCD, top, top, top. See how it's not just one fraction on each side. It's 2 fractions. It's 3 things, not just 2 things, right? It's 3 things. But we know what. It's just like the work problems we started off today with, right? Just look at the LCD, and you just go top, top, top with the LCD. It's just like that 1 over A plus 1 over B is 1 over together. It's just like those work problems. All right, so what's the LCD? There's an X, there's a 2X. Is this in the denominator? No. So it's just 2X, isn't it? Because remember, you just take 1 of each, huh? You just take 1 X, and we don't take both X's, do we? We don't go 2x squared or something. We just go 2 and x, because it's just 1 of each type. That's it. And what do we do? Am I going to do top and bottom or just top? Just top, because I have an equal sign. Yeah, all my thinking is left and right. I'm not thinking top, bottom. So 2x, 2x, 2x. Just like the work problems earlier, an hour ago, right? That makes sense? See why we have to do this instead of just diagonal, diagonal? Because we don't just have 2 fractions, we have 3 things. So we have to do LCD, 1 of each, top, top, top. Now what do we do? Cross cancel. Cross cancel and multiply whatever's left over, right? X cancels X. What's left over? 2 times 80, 160. What happens in the middle? 2x, 2x. What's left over?
80.
Just the 80, huh? Makes sense? Because the 2 and the x both cancel in the middle. Now over here, do I cancel these 2's like that? No, that 2's not under the bar. It's only stuff under that cancels with stuff above, right? So this is just going to be 4x. They just multiply. They're all left over. They're all multiplying. There's no canceling. Do you guys, let me stop, make sure that's clear. See, it's only stuff over and under the bar that cancels. Over and under that cancels, huh? This 2 is not under any bar. He's not going to cancel. He's just going to multiply. Everybody see that? All right, so what do we got? What is that? 80 equals 4x. Let me bring that over here. 80 equals 4x. How do we solve for x? Divide by 4, it's 20. X is 20. That's the key. Let's go unlock the doors they want. What doors do they want? The speed going. Speed going. Where's that? What box is that? They just want one answer. Speed is rate. Do they want this one or the other one? Yeah, because not the return, but that one. So it is just X. So it is just 20. 20. We're done. Answer's 20. That truck went 20 miles an hour on the way there. I've been behind those trucks before.
Well, but it was in a snowstorm.
Yeah, all right. We'll give them the snowstorm. Good there? Yeah. Good? Questions on that? All right. This one is a little bit different. Rob's tractor is just as fast as Gabe's. Takes Rob 4 hours more than it takes Gail to drive.
You said four is only
Someone
two.
cleans man.
What's that?
You said four
Or
miles
just we can't
is
see.
only 2
There
miles.
goes she's.
It takes around two.
They would go there and
2 hours.
go for
I thought you said 4 hours.
Nope, 2 hours. More. 2 hours more. 2 hours more on that one. So this one's a little tricky. See what you can do. So the distance equals rate times time.
It's just a specific. It takes 60 miles from town to 60 miles. 60.
Around 60 miles.
Good. All right, let me jump in and give a little bit. You're supposed to get the left 4 boxes, huh? Right? What is that word just as fast? Just as fast. Equal to. Equal to. What is, we're talking Rob and Gail, and they say just as fast.
So the rate is equal.
So the two rates are equal. But I don't know what they are. I mean, are they like 7 and 7 or 3 and 3 or what are they? I don't know. They're just, all I know is they're same. So what I put in the 2 rate boxes? What can you put in 2 boxes that you know are the same, but you don't know what they are? X and X. Does that make sense? Do you see, guys and gals? They both have to be X, don't they? The 2 rate boxes have to both be X. Right? Because they're the same. They're not saying one's double or faster or slower. They're same. But I don't know what they are, so I can't put in numbers. So it's just X and X. That's the little trick. There. Just as fast. Same. Both. Just. X. Okay. This 2 hours more. 2 hours more. Is that talking about distance or rate or time? 2 hours more. That's time. That's time talk. Don't put that in the time box right now. Just save that 2 hours for later. Remember, how do we get the time boxes? By dividing, right? We get the left 4 boxes first. So just save that 2 hours more. Just save it. We'll do that when we write our equation after we're done with the 6 boxes. Remember how that works? Save the time stuff. And just go on with it. Rob is 60 miles. Gail's 40 miles from town. Those are distances. Rob's distance is 60. Gail's is 40. You know how to get the right 2 boxes now. Right? By dividing. And then pull out those right 2 boxes. And then you'll use the 2 hours more. What are you going to do with the 2 hours more? Just think real life. What if I said, I'm 2 years older than my brother? Really? Is that what you do? If I said, I'm 2 years older than my brother, so you would take my age and you'd add it to my brother's and get 2? If I said, I'm 2 more than my brother, I'm really 3.
Take your age and add 2 and get your brother's age.
You could do that. Oh, no, I'm the older. You would add 2 to the younger person. Yeah. That's one way. That makes sense, but go ahead. But the other thing you could do is take the older person minus the younger. That would equal 2. Yeah, same thing. Yeah. You can subtract 2 from the older, add 2 to the younger, or just subtract older minus younger and get 2. Am I thoroughly confusing you by giving you options? I normally don't give options because that confuses people. When I was a brand new teacher, I thought I'd be really helpful, and I'd show everybody 2 or 3 ways to do all the problems. And they didn't like that. I thoroughly confused everybody. So now I just go one way. So when they say 2 more, remember on the last problem they said 2 less? Whenever they're comparing 2 things, oh, here, I forgot to get these boxes here, 60 over x, 40 over x. So whenever they say 2 more or 2 less, it's the same thing. It means the bigger minus the smaller equals 2, doesn't it? That's what it means when somebody's 2 more or somebody's 2 less. It means the bigger minus the smaller equals 2. It means their difference is 2. They're different by 2. Doesn't it mean that? If somebody's 2 more or somebody's 2 less. Whenever somebody is 2 more, that means the other guy's 2 less. That means they're different by 2. Their difference, their subtraction must be 2. Is that good? So it doesn't really matter whether they say, now I know you might be thinking, wait a minute, Sarah, you said more is always x add 2. And, well, yeah, when we're putting it in one box. I know that's confusing. But yeah, let me slow down there for a minute. There's 2 ways we handle that. If we're trying to stick in a box, which I'm not doing right now, I'm trying to write an equation right now. I'm done with the boxes. I'm writing an equation. That's a different kind of animal. That's a different kind of logical thought. Do you see that? Yeah, if I'm trying to stick something in a box, more means x plus 2 and less means x minus 2 when you're sticking it in a box. True. But when you're writing an equation at the bottom, at the end of the boxes, and they say more or less, either way, that just means they're different. They're just telling me they're different by 2, right? Somebody's 2 more, somebody's 2 less, whatever, they're different by 2. So their difference will equal 2. Does that make sense? So I've got to put the bigger one first, minus the smaller one, and their difference will be 2. The difference in these 2 times will be 2, right? 2 hours more. Well, which one's the bigger? You better make sure when you subtract, you got to get the order right. You got to. If we put my brother's age, my brother's 47, I'm almost 50. That would be negative. That would be wrong, right? You got to put the bigger one first. So which one of those is bigger? How do you know which of these is bigger? It tells you in the words. Speak in English. What's it saying there in the English language? Rob more. Rob 2 more. Rob 2 more. So Rob. That one's 2 more, huh? Does that make sense? Or the number's bigger too. That helps. That makes sense there? Rob's 2 more. Put the Rob one first. These are a little tricky, huh? Can you solve that equation now? It's 3 things, not just 2. We can't just cross multiply, huh? Everybody see that difference? When there's 3 items, we have to do LCD. Top, right? if there's just one fraction on each side, just two things, we just do the diagonal cross multiply. Does everybody see that difference? So this takes a little bit of practice. This won't come to the casual. It's got to be intentional practice to get this down.
Because there's a 1 over here.
If this feels slippery to you, watch this YouTube again and work through these problems
That's
again.
fine. Because of the x is just cancel.
All right, so what's the LCD? Just x. This 2, is he in the denominator? No, he's not part of any LCD. He's not a denominator. The only thing under any bars is x. X is the LCD here. Just x. Good? Does that make sense? So what do we do with the LCD? Top, huh? That's what we always do with the LCD. Top. When you have an equal sign, I mean. Is that good? Can you do the next step? And then cross cancel. So x cancels x, just leaves 60. X cancels x, just leaves 40, and this is 2x. Make sense? Good to there? This is 20 is 2x. Last step. X is 10. Now, how long does it take Gale? 10. Nope, careful. That 10 is the key, but it's not the door. You got to go back to the door they want open. What's behind door number 3, Bob? What door do they want? Yeah, what are they asking?
Time.
How long? When somebody says how long does it take? What are they talking about? Time. They're asking for the time box. Which one? Gale. Gale's time box. Gale's time box. That's the door they want open. Right? They're saying, how long for Gale to drive to town? Time for Gale. So take that 10 and put it in right there.
18.
Everybody see that? So it's going to be 40 over 10. 4 hours for Gale to come to town. Is that good? Does that make sense? How we got our final answers? You got to be careful, huh? You know what they do, guys, also on the exams that sucker people in is they put this as one of the options. Yeah, please don't be sucked in by that. I get these tests off the publisher's web page test generator thing. So I just go in and I say, give me one travel problem. And when I make a test, I go to the web page test generator thing and I go, give me one travel problem, give me one, what was the one we just did, working together problem, give me, one of each, and then boom, it makes the test, and they do the multiple choice options. Well, I've noticed the pattern over the years, they always put this answer, like, as one of the options, like answer C or something, 10, and you're just tempting you, they're just baiting the hook and throwing it in the water, tempting you to grab that 10, so you've got to be self-disciplined and remember that on a word problem, X may or may not be the final answer. You got to take that key and unlock the right door. They want to know if you are careful enough to get the final answer, right? So you got to take that X, read what they want, how long for Gale, Gale time, put the 10 in there, 40 over 10, 4. They'll have that 10 as one of the answers. Suckering you in. Don't be suckered. Be careful. Remember on word problems, X is not necessarily the answer. You got to take your X back and put it in the right box. Questions I can answer on that? Are we good? Saying anything. So we did the hardest. We made it through the worst word problems in the course. There's approximately 3 pounds of muscle for every 4 pounds of body weight of a certain animal. For a 92-pound animal, how much of the weight is muscle? So what are we going to do? These are ratio problems. You can probably sense it even as you read it. I'm going to put pounds over body weight. Pounds over body. Pounds over body. So I'm going to go 3 pounds for 3 pounds of muscle. I guess it's supposed to be muscle over body weight, huh? They're all pounds. Muscle over body. 3 pounds of muscle over 4 pounds of body weight equals, it's just going to be 2 equal fractions. And now, where's the 92 go? Does that go on the top or the bottom? Yeah, ask yourself, is the 92, is that muscle? If so, it goes in the top. Or is it body weight? If so, it goes in the bottom. The 92 is body weight. Yeah, so what do everybody see what I did there? So I just took the 3 and the 4, and I just made a fraction. I wrote muscle and body just to help. You don't have to write that, but I think it helps. Equals, and the 92 goes to the bottom because it's body weight. Body to the body. What do you put in that blank in the upper right, do you think? There's my x. How do you solve when you just have 2 equal fractions instead of, I don't have like a plus 10, I don't have 3 things. If I had 3 things, I'd have to do LCD, huh? But if you just have 2 things, what do you do? Diagonal, diagonal. 3 times 92, 4 times x. What is that? Oh, and you could even, how do you finish getting x alone? Just divide. So I would just divide. I wouldn't even figure out what that 3 times 92 is. Just divide by the 4 and do it all at once. What is it, 60-something?
69. I did put 7 5 times 92.
Great. 69. 69 pounds of muscle done. Super easy. This will be your favorite kind of word problem. Does that make sense? Everyone, we'll do a couple more, but everyone's just going to be 2 equal fractions. These are called ratio. So we've had work, travel, and now ratio. This is the last kind. The easiest kind. Questions on that one? So how are you going to recognize these? They give you 3 numbers. They always give you 3 numbers, and the 4th spot's an X. It's not a travel. It's not working together. So you'll recognize it on the exam next Monday, because we've only got 3 types. It's either travel, working together, or this kind, ratio. They give you 3 numbers. And I would suggest you put 1 of each type on your 3x5 card, especially the travel. Put a whole travel problem on your 3x5 card. All the steps and everything, if you want. And 1 working together and 1 ratio, if you want. Okay. Let's try this one. Okay, 10 cubic centimeters of a normal specimen of human blood, 1.2 grams of hemoglobin. How many grams does 45 cubic centimeters of the same blood contain? All right, see how they have the 3 numbers? 3 numbers, so make a fraction. 2 equal fractions. Only thing is to be careful where the x goes. And what can help you is if you want to write in some kind of units. Might help. You don't have to, but it would make you more careful. Okay, so I'm going to go like 10 over 1.2. Is that good? And what is that? The bottom is the hemoglobin. How about I just write that? You don't even need to write both things. I just got whatever over hemoglobin. Now, on the other side, where's the 45 go?
The top.
It goes to the top because it's not hemoglobin.
The X is
And this will be X. Everybody see why I know the X goes on the bottom this time? Last time it went on the top. It's because I'm following the units, right? Yeah, you can do cubic centimeters and grams if you want, or whatever helps you remember. Everybody see that? So 10 cubic centimeters to 1.2 grams is 45 cubic centimeters to what? Is that good to there? Does that make sense? To see how I know where the X goes? And then we go diagonal, diagonal. 10x is 1.2 times 45. And then I would just divide. I'd divide by the 10 right away. Is it 5.4? 5.4. We're done. Is that good?
Why do all of that when you can just do 45 divided by 10 times 1.2?
Totally great. You're exactly right. You're comfortable with that? Know how to do that? Do exactly that. You're right. And you're feeling what it's doing. That's exactly right. Feeling is always better than mechanics, if you can sense it. Good. Questions on that one? Are you okay with that? So see how it works. So when you read these, just two equal fractions, and the units I think will help. Cubic centimeters over grams. Cubic centimeters over grams. So I did the x one at the bottom because 45 was cubic centimeters. So I put the top on.
I'm just trying to see.
Right. Okay. Okay, try that one. One pound of honey requires 20,000 trips by the bees. I have a peanut butter and honey sandwich at least 4 or 5 days a week. I'm just making those bees work. 1 pound, 20,000 trips. How many pounds for 65,000 trips? So two equal fractions. One of them's got an x. And you can even do the fractions upside down as long as you're consistent. As long as you're doing them both the same way, it'll all work out. So I'm just going to put 1 over 20,000. I'm putting pounds over trips. But you could do it the other way. It's fine. As long as whatever you decide to do on the left side, you do on the right side consistently. So I put 1 pound for 20,000 trips. And so then when I do the 65,000, that's going to go on the bottom. And this will be x. And then diagonal, diagonal. 1 times 65,000 equals 20,000 x. That good? And then just divide both sides by the 20,000. And what's that answer? 3.25? 3 1/4 pounds of honey. I probably eat that every month. Questions on that? We good? There's a couple tricky ones coming. Can I move along? Okay, so the trick on this one is they're giving you the ratio of copper to zinc is 1:21. So you can write it copper over zinc. They're giving you the whole left fraction. Does that make sense? They're giving you the whole left side. Copper over zinc, 1 over 21. Zinc's a lot heavier, I guess. Okay, then see, now you've got to decide where should the 59 on the other side. Where should the 59 go? Should it go on the top or the bottom? Yeah, it's zinc, so it goes to the bottom, huh? Yeah, it's zinc, so it goes to the bottom. 59 kilograms of zinc. 59 for the zinker. Oh, you guys got that copy down? I got to recharge mine. So I'm going to have to disconnect for a second. Charge up my pencils. Tired. It's out of juice. All right, I think we're good. Okay, so the what is it? The 59 goes on the bottom, like that, and then because 59 is zinc, and you go diagonal, diagonal. So 1 times 59 is 21 times x. Last step, divide by 21. Somebody got it? 2.8. Thank you. X is 2.8, and however many, or whatever. I don't know if they want a fraction, decimal, whatever. Test, I don't care. All right, that one's an interesting question. How do they count deer on the mountain rabbits in the field and fish in the lake. You ever thought about that? How do biologists count critters when you got a bunch of them? I mean, how do you count fish in the lake? That's the best example. I mean, you go 1, 2, 3. How do they need to estimate, fish populations, and they need to distinguish like trout from bass and things like that. And park rangers, biologists, conservationists, they need to say in this lake we estimate there's about 2,000 bass or so. How do they do that? I mean, just because they think, well, they poured them in, they know. Well, yeah, but then they die and they give birth, and how do they know, a month later, how many bass are in that lake? How many trout are in that lake? What do they do? Ever thought deeply about this at night? How do they know that? How do they come up with those numbers? What do they do? Do they go over the top with a sonar device? Can you imagine trying to count those little bleeps? Was that a trout? No, that was a bass. I can tell, they're all moving around. No, that's not what they do. It's not technology. It's not technology that's answering this question. How do they count them? Catch, tag, and release. Catch, tag, and release. They've been doing it for decades. What they do is they catch a bunch of the critters, whether it's rabbits or deer or fish. They'll throw in a net, or they'll grab the deer, or they'll grab a bunch of the rabbits, and they'll tag them. They'll put a tag on them. And then they'll release them. And then like a week later, 2 weeks later, give them some time to mix around. They go out and make another random catch, and then they look at what they've caught. And the percentage that have tags, tell them the percentage that have tags approximately of all the fish or deer or rabbits, and then they can estimate the number that have a certain type. For example, let me appeal to you logically and show you how that makes sense. What if I told you what if I told you that we catch and tag, I don't know, 100 fish. Catch, put a tag on, 100 fish, and then release them. Catch, tag, and release 100 fish, right? And then 1 week later, the fish all swim around. We catch at random. We do a random catch, just throwing down a big net, pull up, random catch of, 500 fish. 500. Well, let's just do less. Let's make it simple. Catch, 40 fish and find 20. Well, let's just do 30. Keep changing my mind. Let's just say we catch 30 fish and we find 15 have tags from last week. Right? Think with me logically for a minute. I bet if I talk with you for a minute, you'll know the answer. And what's the question? The question is, how many, approximately, this is an estimate, it's not exact. Approximately how many fish, whether these are trout or bass or whatever, in the lake? All right, so think with me. I bet you can, if you just think about the numbers for a minute. We caught a bunch of fish. Don't even worry about the number. We just caught a bunch of fish, tagged them, released them. They swim around for a week. Random, we throw down a net, we pull up 30, we sort them out on the boat, and we find that 15 are the ones we tagged from last week. 15 of them are new fish that are not tagged. If you grab at random, throw down your net and pull up at random 30 fish the second week, 15 having tags, what portion of your catch had tags? Half, right? Half. So you're thinking probably about half of the fish in the whole lake have tags. I just threw down the net at random, pulled up 30 fish, and 15 had the tags from last week. Probably half of that whole lake. Now that's where you're not exact, but it's probably pretty close. Just like polling is what they do for an election, right? What percentage are going to vote? This way they try to estimate what the whole nation's going to do before election day. Same thing, we're polling the fish. We're asking the fish, so to speak. We're grabbing the fish and seeing if they have tags, right? So we're pulling them out and we say, all right, about half the fish, right? Half the fish in our little sample had tags. So probably half the fish in the whole lake have tags. Well, we know exactly how many fish have tags because we tagged them. A week ago, we tagged 100 fish. And so we know there's 100 fish out there with tags, assuming none died. I mean, it's a little bit of a rough estimate, but probably pretty close. In a week, probably not too many died, right? So we know there's about 100 fish out there with tags because we tagged them a week ago. And we know, because of our sample the second week, that about half the fish in the lake have tags. So there must be about 200 fish in the lake. Does that make sense? Because we know 100 have tags, and that's half. So it must be about 200. Do you see how we're able to estimate that? Does that make sense? Right? If I told you, hey, I'm going to go around Fresno City and ask people, if we had a re-election, who would you vote for? And maybe I asked 10 people, okay, at Fresno City. I just want to do a Fresno City poll. Think with me this way. 10 people, and 5 say they would vote for Miss Hillary Clinton if they could do the election again. 5 people, 5 out of 10. I just asked at random. So that means maybe, if I did that randomly, half of the whole student population would vote for Hillary Clinton if we had to do it again. Right? Half. And I tell you there's, how many are here? Like 20, I don't know, 23,000? Something like that. 23,000 students at Fresno City College. If I said, yeah, I asked 10 people, half would vote for Hillary Clinton. So how many would vote, how many of the whole 23,000 would probably be in favor of Hillary Clinton? Well, half of 23,000, whatever that is, huh? Well, yeah, whatever 12. So you see what I mean? Whatever portion this is, that must be the portion of the whole thing. Does that make sense? That's the idea with polling, right? So if half, 15 out of 30 is half, is that on the screen? Yeah, is half. If half of the whole lake has tags, and 100 have tags, the whole lake must be 200. Because half of them have tags. 100 is half of 200, isn't it? Does that make sense? If I know half from my sample of catching, 15 out of 30 had tags, I know half the lake has tags. I know there's 100 that have tags, must be about 200 in the lake. See how I'm able to use those numbers to estimate how many in the whole lake? I'm going to give you a formula to make it not so, touchy-feely in a second. But I just want to give you a gut level feel that, yeah, that makes sense, doesn't it? It's a way of polling the critters, so to speak. That's how they do it. That's modern. You read Field and Stream and stuff like that. That's what they do. That's what biologists do with rabbits in the field and deer and fish, animals, critters. All right, so let's do it now. Now that we've got the big idea, let's get to the particulars. So they use math to estimate. All right, here we go. So basically you do tag over total. Here's the actual formula, is tag over total. And this is first catch, and this is second catch. Tag over total equals tag over total. We're basically doing ratios. It's this third kind of word problem, ratio, that they're using a ratio to do it. Tagged fish over total fish in the first catch equals tagged over total in the second, because the ratio's not going to change, right? In a week, it's going to be the same portion of tagged fish or rabbits or deer. So here we go. Determine the number of deer in a game preserve. The conservationist catches 385, tags them, and lets them loose. Catch, tag, and release. So that goes right there, doesn't it? That's 385. That's the tag number in the first catch. Good so far? Later means what? Second catch. Later, second catch. But I can't even see that number now. What is that? 362. Later, 362 are caught. 181 of them had tags. So 181 out of 362 in the second catch had tags, is what they're telling me, huh? Everybody see that? See how in the second catch, 181 out of 362. I was that rocket problem makes me. Can I tell a story? The story comes to mind. I worked in summers when I was going to college forever. I worked summer jobs a lot. I get summer jobs. I got a summer job at Aerojet one summer doing a database entry. Which is a defense contractor. So I was working with the people that make rockets and things. Right? I was just the little data entry guy. I was nothing. But anyway, I overheard them talking one time. I thought it was really funny. One of the scientists was saying to one of the other ones, he was saying, yeah, I ordered the rocket motor part, and they got the wrong address and tried to deliver it to my house this weekend. Can you picture that? Right? They're knocking on the door, right? You open the door, and they're like, we got your rocket engine. And like you're in your suburban neighborhood, right? And parked in the, there's a semi with a rocket engine on it.
Oh my gosh.
No, deliver that to work, please. Not my house. I just thought that was hilarious. Tried to deliver it to his house. All right, so complex fraction, fractions over fractions. What are we gonna do? Well, basically, you're gonna take the LCD and multiply the top of all terms by the LCD. So, what is the LCD? As you look at all those little, it's 25. Can you see it? It's just this guy, right? Because the 5 and the 25 are the only denominators, first off. And 5 and 25 both go into 25, don't they? We good with that? So 25 is, if you did them in a box, you could do that if you want to be formal. You'd say 5 goes in there once, goes in there 5 times. What goes into 1 and 5? Nothing. Multiply these guys together. What do you get? Sure enough, 25. All right, so we already knew it. LCD is 25. So what do I do with that 25? 25, 25, 25, 25. See what I mean by everybody? Notice am I doing left and right, or am I doing top and bottom? Well, I'm really doing top and bottom. Why? Because there is no equal sign. Remember the thinking? There's no equal sign anywhere, so there's no left, right. There's only top, bottom, right? See how it's one or the other? Always in these fraction situations, it's either left, right when you have an equal sign, or it's top, bottom when you don't. So top and bottom, everybody by 25, because that's the LCD. We're trying to make this thing cleaner. You guys know what I mean? This is a big ugly mess, isn't it? We call this a complex fraction because it's fractions over fractions. It's a mess. We don't like it. We want to make it simpler. All right. So how do we simplify this now? 25 times 1. Let's bring it down here. It's just 25. Right here, cross cancel. Remember, things under the bar cancel out, don't they? So just have 4, huh? Good so far? Right here, they're just going to multiply because there's nothing under the bar there. Nothing under the bar. Plus, what's going to happen right here? Is there something under the bar? Yes. So 5 goes into 25. They're gone 5 times. Cross cancel, huh? Like always, whenever we have something under a bar, it cross cancels with what you put next to it or on top of it. And what's left over there? 2 times 5? Oh, it's supposed to be minus, huh? Minus 10. Did everybody see that? Right? You cross cancel. These are gone. And multiply the 2 things left over, huh? So then what is that? 25 plus 4? 25 minus 10. Done. Much simpler, huh? We cleaned it up quite a bit, didn't we? So you multiply the top and the bottom by what is missing, or not missing, okay, by the LCD. Top, right? The LCD, top and bottom of the overall fraction. So we're going to do a bunch. That's what we're going to start with on Wednesday, and then we're going to do even more word problems as well. Wednesday is a big day for us, but first, we need a free clicker. Let me get it going here. All right, it's open. A for apple, and we're done. So the only section due on Wednesday is 6.7. All those word problems, travel and ratio and working together, those are for Wednesday.